Imagine you have a bunch of items that you want to keep track of. This could be in an inventory, it could be in your classroom, or it could be in your pet clinic. You're, you're not going to scatter these items around. You're going to put them inside a container and you're going to organize these items in a certain way. In programming, this container is often a list, and Kotlin gives you a list of T where T stands for a type, and list of type is a fantastic tool for you to organize your items. So your list of T or your container, the real magic begins when we put different kinds of things into the container. So we are going to see what can we put into this container and how do we organize things inside the container. If you're managing a grocery list, let's say you are managing a container of fruits. So in Kotlin, when you represent this programmatically, you're going to use a list and you are going to use the list of function and you are going to put your fruits inside this basket. So I created a variable called fruits and I have put three fruits into this basket. So what if I want to print each of these fruits? How do I do it? I can use a for loop in which I say fruit in fruits. So fruit here can be anything. It can be any variable that you declare. And in here tells the compiler that you are going to search inside some list. So fruits here is a list. So fruits here contains a list of fruits. And when you say fruit in fruits, you are going to loop through this list and you are going to print each element. So when you say print fruit, it's going to print, it's going to loop through this list and it is going to print every single fruit in the fruits array, in the fruits list. So you see the output, how it's going to loop through this list and it's going to print every single fruit. So fruit actually is nothing but a list of strings. It's a list of string. So what this means is this list can only contain strings. If you try to add an integer, the compiler will throw an error saying the type mismatch, inferred type is integer but string was expected. So you cannot add integers into a list of strings. So what we see here is an example of grouping similar simple pieces of data. Fine. So what if we are managing a list of students in a class? Each student isn't just a name, they have a name and a grade. We model this with a class, then we can create a list of student objects. So let's say we had a class called a student. We created a list of students now. You see how previously we had created a list of strings. Similarly, we have now created a list of, okay, this list has to be list of, list of students here. So you see, instead of strings, we can also add objects into a list. So that's what we are trying to demonstrate through this example. So our list can also hold complex objects, not just simple strings. So similar to this for loop, we can now loop through this list of students. So I can say s in students, where students is the list, print. Now we know how to access the properties using objects. We know that all you have to do is object name dot the property name. That's what I've done here. When I say s dot name, so s here is an object of type student. Why is that? The compiler here knows that students here is a list of list of student. Okay, student here is a list of student. So there is, so when I give this for loop s in students, the compiler knows that students is a list of student. Therefore, every element in the list is an object of type student. Take this, in this example, the compiler knows that fruits is a list of string. So every element in the fruits list is a string. Now every element in the students list is a student. Now if I try to print this, since it's a student object and I'm able to assign a variable for the object, and that variable is s. So when I say s dot, so you see here, it's local val s colon student. So s is an object of type student. So I can use this object to access the name and grade property. But if I don't give this curly braces, it is not going to print the correct value. In fact, it prints the object. So I need to give a curly braces if I want to, if I'm going to access properties. So here it says Jack scored 90, Joe scored 99, and STR scored 90. What we have seen through these two examples is that list of T can hold any type of object you define, but it can hold only one type of object. So if you define list to be a list of strings, you can create a list of strings. You cannot put an integer into it. Similarly, if you declare your list to be a list of students, you can only put a list of students into the list. It is going to contain only students objects. So what we can see through these examples is that your list of T can hold any type of object that you define. And if you define it as list of string, it can hold only strings. And if you define list of student, then it will contain student objects. So this is where things become really interesting, leading directly into the power of inheritance. So imagine we have an animal clinic and we have various animals like dogs, cats. So dog and cat are different species fundamentally, but they are both animals. So we have a class here to represent an animal in our animal clinic, and it has a single property called the name. We have a function called speak, in which in the animal class we say it makes a sound. Similarly, we have another class called dog, which is going to inherit from the animal superclass. Dog overrides the speak function, and it has its own speak function where it is going to print $name says woof. So here it says makes a sound. Here we say, no, I don't want the speak. I want a specialized function for speak. So dog says woof. And cat is also a subclass of animal, and cat says meow. So this in this example, so let's say we declare an animals array. So we are going to, so we want to do something with a list of animals. Maybe we want to have a container. We want to do some processing with a list of animals. So I'm going to say list of animal equals list of, and the interesting thing here is, even though we have declared a list of animal, we can put a dog into this list. You'll see how that works. So I'm going to put a dog into this list, and I'm also going to put a cat into this list. You see that there is no compiler error. So this works fine. The reason for this is Kotlin knows that dog is a animal, cat is a animal. Kotlin understands that any function or any property of animal is also available to dog and cat. So Kotlin does not see any problem in adding dog and cat to a list of animals list. So animals is a list of animal. I can add subclasses to this list. So let's loop through this. So this is where something very interesting happens. I'm looping through these list of animals, and I call the speak function in this list. For each item in that list, I call the speak. So first, I'm going to call the speak on the dog object, and here very interesting thing is Kotlin knows that dog, it is a dog object, and it calls the speak of the dog. So that's why you get Luna says woof. Similarly, Kotlin knows that the second element in the array is a cat, and it calls the cat speak function. So even though we told the compiler that, hey, we are creating a list of animal objects, Kotlin is very intelligent, and it understands that each each object is of a subclass of animal, and then Kotlin knows that if you call functions on that object, then it would first go and call the function for the subclass, and only if that is not there, if the function is not there, it would then go and call the superclass function. So if the speak was not there, let's run this. You see that Luna makes a sound. So Kotlin first checks if dog has a speak, and only then if it doesn't have a speak function, only then it goes to the superclass speak. So this is what we call as polymorphism. So polymorphism means treating different objects the same way, but getting behavior specific to their actual type. So we treat different objects the same way. We treat a dog, cat, maybe a parrot. All of this are treated like an animal, but we get a behavior, this behavior which we are getting, the speak behavior, we get this behavior specific to their actual type. And this is what we call as polymorphism in object oriented programming.